Alright, simple harmonic motion. Simple harmonic motion is again like another question that is popular in ways. Almost every year you see a question in simple harmonic motion. Please do familiarize yourself with SHN. Okay, simple harmonic motion. Right, so what is simple harmonic motion? It is simply a type of rectilinear motion. Okay, rectilinear motion means you move on a straight line. Okay, and the three things that you must know about rectilinear motion would be displacement or distance, velocity or speed, and one last one would be acceleration. Okay, so how do you represent displacement? In this case, you're going to have x to be represented as x to be used as displacement. If you were to differentiate this displacement x, that is when you will get x dot. That is when you get x dot, alright, or you get v, which is your velocity. If you were to differentiate your x dot one more time, that is when you will get x double dot, and that is what we call acceleration, or we use a to represent x double dot, which is acceleration. Okay, so when do we use this dot and double dot? Note that dot and double dot can only be used when you're differentiating something with respect to time. Okay, so you're going to have simple harmonic motion to be represented by the equation of x double dot equivalent to negative k square x, or a equals to negative k square x, or d square x over dt square equals to negative k square x, x being displacement, x double dot a or d square x over dt square being acceleration. Okay, so when you look at a equals to negative k square, it simply means your acceleration will be proportional to your displacement, but both will be in opposite direction. Okay, so your k is the constant of proportionality. So to prove that something is simple harmonic motion, you must be able to write an equation that is of the form a equals to negative k square x. That is when you can conclude that this particular motion is simple harmonic. Okay, so let me give you an example. If I were to have x equals to 5 sine 3t, for example, and I say prove that this is a simple harmonic motion. So how then do I prove this one? Again, I needed to write in such a form, isn't it? I needed to write in such a form. A is equals to negative k square x. So what should I do? I'll have to differentiate in such a way that I get my a in terms of x, you see. So I'm going to go with v to be equivalent to x dot, because I'm differentiating with respect to t, you see. So it can be written as x dot. If I were to differentiate, I'm going to get a 15 cos 3t. So what about my a, which is my x double dot? I'm going to get, if I were to differentiate this v with respect to t, I'm going to get negative 45 sine 3t. So can I write a in terms of x? I can. And how am I to do it? I'm going to have my 5 sine 3t to be written in bracket. Okay, why is it 5 sine 3t? Because I needed to bring in my x. So what do I multiply? Okay, in order to get negative 45, again, I need to be putting a negative 9. So when I look at it, a is equals to negative 9 x, and therefore this is simple harmonic motion. Okay, so what is with the 9 over here? 9 is simply k square, and k square is the constant of proportionality. If you were to solve for this k square equals to 9, you're going to get k equals to 3, and you will see that k equals to 3 is simply the number of cycles. Okay, we are going to talk about that later. Okay, so what are the positions that I got to recognize when it comes to simple harmonic motion? I must know where is mean position, or we call it the center of motion, or we call it the equilibrium position. I must know where are the extreme positions. Okay, so mean position simply means x equals to 0. Okay, and extreme position simply means that the furthest point that you could reach, and it is x equals to a, or it could also be x equals to negative a, right? And when at the extreme positions, do note that I always have the turning point to be there, hence v is equals to 0. Okay, on the both extreme positions. Okay, so what then is this a? A, the magnitude of a, okay, a modulus of a is equivalent to the amplitude of the motion. Okay, and that is the positive a and the negative a would be the furthest point that you can reach. Alright, so what are the x, what do I call functions that I use if I were to start from mean position? Okay, mean position means I started from x equals to 0, and to complete one cycle I must have started here. I must have moved to one far end, I must have moved to another far end, and I'm going to come back here again at x equals to 0. This is what I call completing one cycle, and I've started from mean position. So what x function do I use to represent? The best to model such, what do I call motion? Okay, a motion that starts from mean position would be x equals to a sine kt. Okay, and note that a is the amplitude, x is the displacement, t is time, and k is the number of cycles. Okay, right? So start from extreme position means you're going to have an object to start from one extreme, and it will move all the way to mean position, and move all the way to another extreme, and it will come back to the original position. This is what I call one cycle. It could also be starting from the positive extreme, and again it is going to go in such a way that it will complete a cycle. And what sort of x do I use to represent or to model such a motion? I'm going to go x equals to a cos kt. So what happened if I were to have something to start elsewhere? Okay, so it means to say, like, you know, I didn't start from mean position, I didn't start from extreme position, but I started elsewhere. Elsewhere means in between lah, in between your extreme position and mean. Okay, so what sort of x do I use to model such a motion? I'm going to go x equals to a sine kt plus delta, and x equals to a cos kt plus delta, whichever that you use. So what is this delta? Delta is just phase angle, and this delta changes depending on, like, you know, the initial position of your starting point. Okay, alright. So what then is period? Period is simply, like, you know, the time taken to complete one cycle, and it is 2 pi divided by k. So k again is the number of cycles, and this k can be easily found here or there. Okay, right? And how did I get all this? Like, you know, if question were to ask, okay, now tell me what is the minimum displacement, or now tell me what is the maximum displacement. What then is the minimum velocity? What is the maximum velocity? And what about maximum and minimum acceleration? How did I decide on negative modulus of A, positive modulus of A, negative modulus of AK, and like, you know, positive modulus of AK, and negative modulus of AK square, and positive modulus of AK square? How did I get all this? Let's look at this example again. We have got x equals to a sine kt plus delta, and that is my displacement. We all know to draw the graph of sine. Am I correct? Yeah, so if I were to draw the graph of sine, we all do know that sine graph always oscillate between -1 and 1. Am I correct? So the maximum is always 1, and the minimum is always -1. So if you were to have your a to be multiplied into this a, 1 and -1, that is when you're going to get a and -a, and that is how we got minimum of x to be negative modulus of a, and the maximum to be the modulus of a. Okay, and what then about v? If you were to differentiate your x respect to t, that is when you will see ak cos kt plus delta. Again, cos graph oscillates between 1 and -1. So when you have ak to be multiplied to 1 and -1, that is when you will get the most maximum to be ak, and the minimum to be -ak. So that's how I got my minimum velocity and maximum velocity. Yeah, and works the same with acceleration. If you were to differentiate v respect to t, that is when you will get -ak square sine kt plus delta. Sine kt plus delta always oscillate between -1 and 1. So the minimum for sine would be -1, and the maximum for sine would be 1. So maximum of 1 multiplied by ak square will give me ak square. Okay, and the minimum, -1 multiplied by ak square, would give me -ak square. Alright, so to understand how simple harmonic questions can be asked, like, you know, in exam, I urge that you look at the examples on page 116 to 120 in manual 2. Okay, and if you face any problem, do come and look for me. Okay, so that is about the summary of simple harmonic motion.